Okay, class, today we're going to talk about the Bohr models and the distribution of electrons in elements. So let's start at the very beginning here. Now we'll look at the periodic table of the elements and see that the first row, rows are across, or period, has two elements in it. The first element is hydrogen at number 1, right here. That number 1 means he has 1 proton in the nucleus, and he also, and we're all talking about atoms today. Today we will only talk about atoms. He has 1 electron in the shell. Let's go to helium. Over here in the second position, meaning that he has 2 protons in the nucleus and 2 electrons in the shell. Now, you notice that's it. We're done with the first row. That's the first row or first period is in the first electron shell. It can only hold 2 electrons. It's a very small electron shell. So now we have to start a new row. And everybody in the new row, notice they all have these same 2 electrons. I already put those electrons in there. And this time lithium has 1 electron, so for a total of 3 electrons. Beryllium is in the 4th position, so he has 4 protons in the nucleus and 4 electrons, 2 in that first shell, 2 in the second shell. I'm going to keep filling it up, and you notice the second row has 8 elements in the second row. That's because the second electron shell actually holds 8 electrons, not like the first one that only holds 2. So carbon has 6 total. That'll be 2 in the first shell and 4 in the second. Nitrogen has 7 total. That is 2 in the first and 5 in the second. Oxygen has 2 in the first and 6 in the second. Fluorine, we're getting closer to filling it up, and this is why fluorine is ever so reactive, because he is an almost full electron shell. He would love to get that last electron. And neon has a full first shell, but he also, now he completes the second shell because he has 8 electrons in the second shell. Notice helium has a full first shell with 2 electrons. Neon has a full second shell with a total of 10 electrons. Let's go down to sodium. I already filled in the first 2 electron shells, so sodium has 1 in the outside, magnesium has 2, aluminum has 3, silicon has 4. Doesn't matter where you put them because there's certain things we can tell about electrons. We can tell which electron shell they're going to be in, but we cannot tell their exact position. And phosphorus, you see, has 2 full shells and 5 in the outside. Sulfur has 2 full shells and 6 in the outside. And chlorine, just like his buddy above, is almost close to being full. Again, that's what makes him so reactive. And then we have argon, who has a full outside shell. So let's see if we can recognize some patterns. This is where we're going to stop. And let's just see what we can discern from this. These guys in the last column or family have full electron shells, and they're called the noble gases. Noble means that they do not react. This second shell is so close to being full. It is only 1 away from being full and happy and non-reactive like the noble gases, that they're very reactive. These are called halogens. On the other end, though, everybody in the first column or family has only 1 valence electron that they're really happy to give away, that 1 electron in the outside shell. That's what a valence electron is. These are called alkali metals. The desire to give away that last valence electron, means that he is also a very reactive metal, so much so that he's not found in nature by himself. And these are alkali earth metals. Also pretty reactive, not quite as reactive as alkali, but never found in nature by themselves. Now, I want to point out one thing in the periodic table of the elements that's not here, and that's what's called the stair step. Everything above the stair step here are nonmetals. And everything below the stair step here are metals. As a general rule, metals tend to lose electrons and nonmetals tend to gain electrons. So for today, that's as far as we're going to go.